Hello and welcome back to Transport Support 101. Today we are going to go over what shear stress and shear strain are. Let us look at an example where shear stress and shear strain affect how a fluid will flow. Let's say we have a fluid sandwiched between two large plates. The plate on top remains stationary while the bottom plate moves with some velocity v. How will the fluid move? The fluid will have a velocity profile like this. This is because at the fluid plate boundary, there is something called the no-slip condition, which is exactly what it sounds like. The fluid and the plate cannot slip away from each other, which means that the fluid will have the same velocity as the plates. This velocity gradient, or shear strain, between the top and bottom of the fluid is what causes shear stress. Before we continue, let's define what shear means. Shear just means parallel to the surface. Now that we know what shear is, shear stress can be defined as an internal force that is applied parallel to the surface of the fluid. It is typically represented by the symbol tau. Shear strain is the measurement of the deformation of a fluid, caused by a velocity difference that is parallel to the surface. And this is represented by the Greek letter gamma. Now that we know what shear strain and shear stress are, what is the relationship between the two? Well, shear stress is proportional to the differential change of shear strain over time. After simplifying, we end up with this equation. Which is Newton's law of viscosity. Using this equation, we can clearly see that the shear strain is proportional to shear stress through mu. Mu is the symbol for viscosity, which is the measure of a fluid's resistance to flow. Revisiting the plate example from before, we can see that shear strain is the velocity gradient, while the shear stress profile will look like this. So, the relationship between strain and stress can help us determine the type of fluid we're dealing with. We will dig deeper into viscosity and the mathematical expressions for different fluids in the next video.